so now we're going to start on graphs of polar equations. We already started on the actual polar equations. Now we're going to work on the graphs. And we're going to start with symmetry. Okay. So starting off, we're going to compare symmetric functions to symmetric polar equations. Okay, so let's say if you have the graph, you have your x-axis and your y-axis. So let's say you have a graph that looks like that, where for every x comma y, you have a negative x comma y, which means it's symmetric across the y-axis. Which in this case is an even function. If xy and x negative xy yield the same equation, or yield equivalent. So if you replace x with negative x and you end up with the exact same thing, you know you have an even function. Okay, it's pretty similar for polar equation. Okay, so let's say if we have a graph where instead of y function, this is 0, this is our thetas, pi over 2, pi, 3 pi over 2. Don't know why I keep doing that. Okay, so this is our polar, I guess you could say polar graph. Okay, so let's say here, say we have some point r theta. Okay, in this case, let's say instead of r and then theta, we go negative r. Quick little reminder that theta is counterclockwise. Okay, so remember, theta goes that way. And negative theta is clockwise. So negative theta, remember, goes that way. Excuse me. Okay. So if you go negative r, and then go negative theta, you're going to go that way. Okay. If it's like that for every single point, then you know it's symmetric across the axis. Instead of y-axis, well, you could call it y-axis, but they call it theta equals pi over 2. Okay, so that's just a little side note. Symmetric across the axis, theta equals pi over 2, if replacing r theta with negative r negative theta yields equivalent equations. So in other words, you replace every r with negative r and every theta with negative theta. If you get the exact same thing, then they're equivalent across the axis pi over 2. Straighten that up a little bit. Any questions on that so far? All right, I'll leave that up for a few seconds. Okay, or if you want to, which this one isn't used very much, but you could replace r theta with r pi minus theta. There are a couple other ones, but like I said, you can use either one you want. But for the most part, this is usually the easiest. Okay, so if you went out for your radius, then went pi minus theta, it would put you at the same spot. So. All right. Okay, so let's say if we go back to some function, and let's say you have this graph here, and this graph, well, it's supposed to be symmetric, so let me try and draw it symmetrically. Oh, that's symmetric enough. Okay, so let's say you have some point x, y, some point x, negative y. Okay. So that's symmetric across the x-axis. If xy and x negative y yields the equivalent equations. In other words, you replace every y with negative y, and you end up with the exact same, well, you can't even call it a function, exact same equation, then you know it's symmetric across the x-axis. Okay. Like I said, it wouldn't be a function because it fails the vertical line test, but general idea. Okay, so similarly, okay, so they have 0, pi over 2, pi, and 3 pi over 2. Okay, so let's say you have some point here, so this is your r theta, and you have some point here, so we know starting from your polar axis, that's your theta, which is going counterclockwise. Remember, going clockwise is your negative theta. So it's the same radius, you're just swinging the axis in a different direction. So this is your r negative theta. Okay, so this is now symmetric across the, I guess you can call it polar axis, which once you get to polar coordinates, that's just your x-axis. If replacing r theta with r negative theta, give you an equivalent equation. Yields an equivalent equation. That should be an equivalent equation. Well, not really, should be equations because it's more than one. So I guess I was right the first time. Because remember, there are infinite number of solutions for polar equations. simply by adding or subtracting 2 pi. Okay. And once again, this is the easiest way to find out if it's symmetric across the polar axis. There are others, some, let's say your r theta or r negative theta. Uh-oh, that looks like a, with negative r, pi minus theta. Okay, so if you have negative r, let's say you're starting from this point. If you go negative r, then pi minus theta, you're going to go pi minus theta, and you end up right there. So like I said, this is the easiest, but sometimes you'll run across that one. I just go with the easiest one. All right, so any questions on that one? All right, leave that up for a few more seconds, make sure everyone's done. All right, looks like everyone's done. Okay, so let's say if we have our x and our y axis, and let's say if you have a graph that looks, well, that should have went a little smoother. Yep, should be. That should be symmetric across the origin, but I'm trying to make it as actually visually accurate as possible, but it doesn't seem to be working, which I cannot draw. But hopefully you get the idea. If you flip it, it's symmetric across the origin. Okay. So in other words, if you have some x comma y, clean that up just a hair. And you have some negative x, negative y. Then this is symmetric across the origin, which we know is an odd function. If x, y, and negative x, negative y. Uh-oh, got my negative. Use equivalent equations. Okay. So same thing if you apply it to, well, not same thing, but pretty similar to if you apply it to polar coordinates. Okay. So let's say here, if you have your point r theta, and we know that our theta is going counterclockwise. Okay. So what if we go negative r theta? Still going counterclockwise, but we just went with negative r. Okay. So if we know if we replace negative r, and we end up with the same equation, then you know it's symmetric across the pole, which in this case is your origin. So with respect to the pole, which in this case is our origin, if replacing r theta with negative r theta yields equivalent equations. Yes.
Could you also say that as negative r theta plus pi?
Okay, negative r theta plus pi. Well, you'll end up back in the same spot. Yep, we're actually just looking for symmetric across any one of those. Now, if you were trying to get to the same spot, that would work.
Okay.
Yep, because you just go negative r, and then pi plus theta, you'd end up right back there.
What about theta plus pi? Like if it were r positive r theta.
Oh yeah, actually, if you want to, there are so many different ways to end up right across there. So if you wanted to use or replace our theta with our pi plus theta. That was what you were talking about?
Yeah,
Oh, okay.
I missaid theta.
Oh, okay. Yep, so you go with your radius theta or radius pi plus theta. Like I said, or you can go pi minus theta, or
Right.
there are so many different ways. Like I said, me personally, I always try to go with the simplest. All right. Any questions on that one? All right. Leave that up for a few seconds, and we'll do a few examples. All right, looks like everyone's done. Oh, anyone's still writing? Oh, we go. All right. Okay, so let's say, for example, let's say we wanted to test r equals 2 sine of theta for symmetry. Okay. So really, we're just going to perform all three of the tests for symmetry and see which one sticks. Okay, so let's say if you want to test with across, oh, why did I put that? The pi over 2 axis. Okay, so remember, to do that test, you place r theta with negative r negative theta. So every r just gets replaced with negative r, every theta gets replaced with negative theta, and we see what happens. Okay, so that means you have negative r equals 2 sine of negative theta. Okay. Now in this one, remember, sine is an odd function. Let's say sine of x, just to avoid confusion, is an odd function. Okay. So remember, when you have an odd function, your f of negative x is equal to negative f of x. Okay. So that means sine of negative theta is equal to negative sine of theta. That gives you negative r equals, well, you could put 2 negative sine of theta. I'll do that. To avoid skipping steps. So you have negative r equals negative 2 sine of theta. And once you divide or multiply both sides by negative 1, you end up with r equals 2 sine of theta. So actually, we know it's symmetric across pi over 2. Okay, so we might as well go ahead and check the other since we're at it. So let's say symmetric across the polar axis. Okay, so that means we have to replace our theta with our negative theta. Okay, so our r stays r. So r equals 2 sine of negative theta. Okay, again, that's an odd function, so we just pull the negative right out to the front. So negative 2 sine of theta. It's not symmetric across the polar axis because it's not equal. R is equal to a completely different number. Okay, so we know it's not symmetric across the polar axis. Okay, so now we try symmetric across the pole or origin. Okay, so that means we have to replace our theta with negative r theta. Okay, so that means we have negative r equals 2 sine of theta, multiply or divide by negative 1, you still get r equals negative 2 sine theta, which is not equivalent to where we started. Okay, so we know it's not symmetric across the polar axis, across the pole. So we know it's not equivalent. All right. So any questions on that one? Yes.
What does it mean to be symmetric across theta equals pi over 2?
That means that pretty much you have a mirror image on both sides.
Over the y-axis.
Yep, over the y-axis.
Oh, and the polar axis is the x-axis?
Yes.
Inward.
Yeah.
Just a trig way of saying y-axis.
Pretty much. Oh, let me write down that that one's equivalent. All right. Any other questions on this one? All right. Leave that up for a few seconds.
What do you want us writing on the final answer to this?
Pretty much just tell me which one is symmetric
Okay.
across. So as long as you show at least one test, I'm okay. So you may test across the polar axis first, and it may hit. So you may, oh, no need to keep going if you already found it.
So it's always only going to be...
In rare cases, you'll have like where it's all three, but that's
Okay.
usually like just a circle centered at 0, 0.
Fair enough.
Because it's
Right,
all of them.
yeah.
Exactly. So that's the only time you'll have it at all three of them will match up.
Okay.
But not the only time, but one of the
Right.
most common times.
Right, okay.
So, all right. Oh, yeah.
Can you show this work as graphically, or is it just?
So if you wanted to graph it, was that 2 sine of...
Is it just more words?
Not really. 2 sine of theta is pretty straightforward. So 2 sine of theta is just that... Well,
Close enough.
yeah, close enough. Okay, so, if it's 2 sine of theta, you have an altitude of 2. Okay, so really it just means that if you flip it across the y-axis, and then flip it again across the x-axis, the exact same thing. So just really going from, if you just go from there to there. Okay. But if it shifts left or right, that may alter it a little bit.
Right.
So, would you accept that as work?
You mean just the graph?
No, not just
Oh.
the graph, but like the graph, and then you put it like, just like at which, like the polar axis, the pi over 2, and the origin.
Oh yeah, if you showed, let's say, like, if you just did this one,
That's all.
and that was, yep, that would be all you need. So, like I said, unless it's one of those rare ones that's all three, it would just be one. Okay. Any other questions on this one? All right. So let's do one more. Nope, and that looks like it's getting ready to shut off. Ooh, bless you. I'll restart it as soon as I write this. So what if we wanted to determine which type of symmetry applies to r equals 4 cosine squared of theta minus 3 sine of theta plus 5 theta.